right, good day everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and joining us today for Using IntelliJ with Develocity AI for Faster Troubleshooting are my two wonderful colleagues, Trisha G. and Laurent Ploix. Trisha is a Java champion, author, and head of developer advocacy at Gradle, and if you've been using IntelliJ IDEA for long enough, then you'll recognize her past advocacy and international profile talking all about that. Laurent is the head of product at Gradle, who joined us from Spotify previously, where he had spent 10 years as a product manager for CI and led their platform insights team. So we're in good company. And today we will explore new ways of making troubleshooting faster directly within IntelliJ IDEs like Android Studio and IDEA using the free Develocity IntelliJ plugin, which was released in June this year and is at nearly 12,000 downloads. So it's growing really fast and people seem to like it. We'll start off with a fireside chat conversation between Trisha and Laurent before going into live demos and use cases with a special preview of what integration with our new Develocity MCP server looks like. After that, we'll take some questions. Finally, this webinar is brought to you by our hundreds of happy customers, including Duolingo, everyone's favorite language learning platform to ignore. I'm kidding. Duolingo's growing Android team uses Develocity for deep observability into their build and test cycles, troubleshooting failures and performance issues using the new Develocity MCP server that I just mentioned. You can DM me privately if you're interested in learning more about that. Duolingo is looking for talented engineers to help them with their Android platform, backend systems, and data science and machine learning pipelines. So go ahead and check out their open positions at careers.duolingo.com. All right, that's all from me. Let's hand it over to Laurent and Trisha. Hey, folks. Thanks for joining us today.
Hello.
Thank you so much, Oliver. Hello, Trisha. So, agentic AI is all over the place, right? In your experience, what is it like to develop in this new world?
Well, we are definitely creating a lot more code, that's for sure. And I think the people in charge of the CI infrastructure are very much aware of the increase in volume and costs associated with this. When you're coding with AI, sometimes you're using something like Copilot or some sort of AI assistant, and sometimes you're using agentic AI of some kind. But at the end of the day, a lot more code is getting pushed. The dream, of course, is that developers can focus on the things which are, the difficult parts, the interesting bits, and the agents can take care of all of the rest of it.
Yeah, I saw some recent statistics that show that there are also some challenges, right, for companies that adopt AI. And you probably read this latest DORA report, right? The state of AI-assisted software development.
Right. I've read a few of these reports, but the most recent one is really interesting. They've got an interesting observation on the DORA metrics, and in particular, the deployment statistics. And it seems like the more you use AI, the longer, and the percentage of failed deployments also increases. And this is a great report. Everyone should read it.
Yeah, that's quite actually interesting, yes. More code gets produced, but it seems that we are losing the ability to understand what it does. It becomes more and more difficult to repair, and when it failed in some kind of way. So we deploy more code, but it's more unstable as well. And it takes us longer to understand the problems.
If you didn't read the DORA report, and this slide kind of summarizes the important parts that we really want to highlight, which is that, that the numbers are, let's not focus too much on the numbers, but the point is like the more you adopt AI, then the more you reduce your software delivery throughput. And you also increase your software delivery instability. Those are not the numbers you want to be increasing and decreasing. There's also another interesting idea, another interesting study about the impact of developers' productivity and how developers perceive their own productivity. So developers often report they're going faster with AI, even if that's not necessarily true. So parts of the development process are actually increasing in speed, such as producing code, but other parts are slowing down, like reviewing code, understanding issues, and fixing them. And we heard quite a few stories like this at DPE Summit that Gradle hosted back in September. So if you're interested in some of that, go ahead and look at the YouTube channel, but not right now. Do it after the webinar.
All right, so agentic AI enables us to produce more code, that's for sure. No problem with that. So now what we need is to deliver more value.
Right. So what are we missing if we're producing more code but not more value?
Well, creating value is a process that involves a few things, right? Numerous activities. And the entire process cannot go faster than the slowest part. So let's focus on developers' activity. What about we list a few of the activities to understand where the bottleneck really is?
Right. So when a developer is producing code or doing something, the first thing they're going to do is like form an intent. That might be something like create a test that checks this thing, or I'm going to fix this incident or this bug, or I'm going to code a new feature. So the first thing you have to do is decide to do something. Then a developer is going to introduce a small change in the code, which will hopefully take it in the right direction. That's the idea. And then you're going to build it and run the tests and make sure everything's working. More often than not, the sort of build and run phase is where you're going to end up with some problems and something starts to break. And so you're going to iterate over this, and we call this troubleshooting. And that's what developers spend a lot of their time on.
Yeah, that's what I observe as well. So when I was a developer, and now that I can see the statistics. So developers spend the majority of their time actually fixing broken builds or broken tests, which means they spend most of their time troubleshooting. And most of the time, it's actually about understanding what the problem really is. So let's talk about the steps: intent, code, troubleshooting. In the world of AI, the intent is expressed as a prompt, and then the code gets generated. The AI agent actually getting better and better at generating more code based on this intent. However, statistics indicate that the troubleshooting part is not progressing as fast, and in some ways lagging behind. So, I mean, if you ask Gemini or any other LLM to parse a stack trace, it actually gives you quite good results. But we need a lot more than that. And why is it? Because there's a lot of aspects of complexity here. You have, of course, so unclear messages, but there can be infrastructure issues which are not under your control. You might want to know if someone else is looking into the problem, if other people have similar problem as you, or maybe you got a flaky test, a flaky product, a flaky infrastructure, etc., etc. And maybe you got like 50 failures in front of you, but in fact, there's actually 2 or 1 root cause for that. So in short, in order to get all the value of AI, we need a much higher increase in troubleshooting capabilities. And it's not about only analyzing a failure in isolation. To do a good job, AI needs to be able to solve all the aspects we just listed.
Right. So what you're saying is that one of the current bottlenecks is the troubleshooting phase. And if we unblock that, we'll get much more value, not just much more code.
Exactly. Trisha, why is it we are even discussing that?
Because we want to do a demo. That's what we're here for. We're going to demo some of the features that have been developed, which Develocity users can use from inside their IntelliJ IDEA IDE, which makes me happy.
Yeah, of course. So you know what? I will show you some typical example of how developers can waste a lot of time, and perhaps even more typical situation where we can waste a lot of time, but with AI-generated code, it can be even worse. So I'm going to actually use this setup. I'm going to use IntelliJ here. Inside IntelliJ, we use the Develocity plugin. And then we will also use an agent which is going to connect to the MCP server, which itself is going to get the data from Develocity. Whereas nothing is that you can actually use the Develocity plugin without Develocity, but you get less value, of course. So here, for instance, I have the Greater project or the Sunlight project. And here, below here, you got the result of the build with the Develocity plugin. You got all the tasks that were run. And for instance, if you click on this one, you're going to be able to see the result of the task. And if you click on this, you're going to be able to see the summary. So this one already with Develocity, which you get in one click from the Develocity plugin from within IntelliJ, you can get an overview of your failure, and you can have, if you want, AI-powered failure analysis, where it says, in this case, okay, you got 8 failures, but in fact, they are all with the same root cause. So that means, well, maybe if you fix one of them, that's going to fix the 8. I want to mention, for instance, this Brazil build, which I run here, is a lot longer. And I'm not going to run it now because it takes quite a long time. But you see all the tasks, you see the failing ones, you see the in this case, the CPU, you can also see the memory consumption of your build. And this is what you get even if you don't use, even if you don't connect to Develocity. One more thing, it's actually very simple with this plugin to connect to set it up so that it connects to where your Develocity here. In this case, that's an open source, that's a public one. So if you install the Develocity plugin in IntelliJ, you can very easily connect to Develocity, and all your build scans are going to be published. I would like to mention that it also works with Android Studio, and it currently works. And what I'm showing you here is how it works with the Gradle build. It will soon work with Maven builds. And behind the scenes, something I'm not going to show you now, is we also have Develocity MCP server running, and we will see how we use it. So it enables you, in short, the Develocity plugin enables you to see the timeline, and it enables you to connect to Develocity in a very easy way.
Great. So, but before we start with the next part of the demo, because that's really just the introduction, what makes it unique? Why do we need the Develocity data to help us with this troubleshooting step?
If we want to have a very effective AI solution, we need three things. We need reasoning capabilities and domain knowledge. We need comprehensive data, and we'll see why it's so important. And then we need a job to be done, a problem to fix, in this case, the troubleshooting aspects. So we get our reasoning capabilities from LLMs, and of course, we can help train them well with evals. We get the domain knowledge from all the documentation, the system prompts we can provide. We get the use case from you, developers. And then there's the data, and that's where it becomes interesting. Because as you know, in the build scans that come from the Gradle, you got a lot of information, a lot more than you can have in the stack traces or other logs. They contain in-depth information about dependency resolution, build flow, infrastructure, where you run, a lot of custom values that you can set yourself, caching aspects, and so on and so forth. Additionally, Develocity captures the build scan from all local NCI builds, which provides context. We know what the other developers face or the CI environment, so there is a lot of context, as I mentioned. And so that means that Develocity itself contains all the in-depth information about all builds, but also all the CI and all the local ones. We'll see in a later example how we use them. And all this data is very unique to Develocity. So we can ask questions that require both depth and breadth, such as, it works on my machine. Why doesn't it work in CI? Am I the only one with that issue? Do other developers experience it as well? Is the dependency resolution different from that of my colleague? All these questions are typical LLM cannot answer by default if they only have access to one specific build. So if you do not have this deep and wide information, then the LLM might hallucinate more and mix things up. I mean, we can never remove all hallucination, but still.
Right. So if we're getting the wrong answers and hallucinations from the LLMs, we're going to waste even more time because they're not getting the right answers. So we want them to have more data so they can give us the best possible answers. Right. So let's see some use cases. Let's dive into some specific problems.
Okay. Here we go. So I hope the demo gods are with us. The LLM does not hallucinate too much. Right. So let's start with a very common case. It works on my machine. So this case requires access to not only my machine, but also some other machines, and typically the CI one.
Yeah, this is one of the most annoying issues when your machine is working and you can't reproduce the problems you're seeing somewhere else.
Exactly. So, and for the first example, I'm going to go step by step. And for the other one, I'm going to take some shortcut and show you the results. So this test passes. It's successful. And if I look in the timeline, it's a pretty compressed one because it's all cached, but you can see all the tasks that were run, and well, everything is green. Of course, I use a zoom factor so that it's easy for you to see, but it looks much better when you don't have it. I'm going to go and ask a question. Let's start a new prompt. Machines accept. Here we go. Please explain why my last build succeeded on my machine, but not in CI. So here I'm going to go step by step. It's going to parse the information locally to find which branch I'm on. And it's going to connect to the Develocity server and fetch information from the local and the CI builds. And at the end, it's going to make a comparison between those two. And IntelliJ enables you to approve the code to NTP server because there can be side effects. As we know, there are some interesting stories about that. All right. I have analyzed the last local and CI build for the current branch here. And here's a summary of my finding. As the local build is this one, the CI build is this one. And the key difference that the two environments are not run, The difference is in operating system is likely contributed to test failure, possibly due to the path and case sensitive issues. So now what it tells me here is that, well, you got the test you run locally, the build you test locally are on a Mac, and they are running differently on a CI.
Right. So this gives me a really good direction somewhere to look for the failures. And these kinds of things like case and sensitivity on one and not on the other can sometimes be difficult to track down because you're looking at the same commands and they don't mean the same thing in different operating systems. So it can be really hard to troubleshoot these kinds of problems. So this is really helpful.
What about we do it the other way around, right?
So it fails on my machine but passes in CI.
Exactly. So this one is going to be more or less the same question. And actually, we could ask a lot more things, right? If it fails on my machine but passes in CI, that's also like a typical case, which is very annoying. We could also ask questions such as like, is it a flaky test? Is it my change that caused the problem or something else? Is it a new infrastructure issue? Is someone else experiencing the same problem? Did that happen on the main branch? Is someone else actually looking into that problem already, right?
Right. These are all really good questions. So let's give it a go.
All right. So for this one, I'm just going to show you what I run, take a bit of a shortcut. So basically asking, my build just failed, compare it with the same in CI. And same thing is going to go, okay, identify what the local build is, fetch the same one in CI, make some comparison. And at the end, I'm going to go directly to the very end. In summary, I did not find any evidence of other... that's not the first one. Sorry. Okay, the build failed because it requires an environment variable that is not set locally. And then it will suggest you modify the test to fix it. And this is an interesting problem because that's these typical environment aspects, such as like in this case, an environment variable can be really, really hard to troubleshoot. And then basically what I'm asking is, do other developers experience similar failures in my branch? So this is typically here where I got a problem here, but I want to know if I'm the only one with it. And in this case, if I go I pass all the steps that it does, you say, okay, the build failure is due to missing environment in your local setup. I did not find any evidence of other developers facing similar issues in your branch. The issue is caused by a missing environment locally, and I can apply a fix. So in this case, it was able to connect to Develocity, fetch all the results from the other developers, and realize that, no, it's actually me that has a problem. The other developers don't.
Right. That's good to know. Like if they had problems too, though, you'd be able to share it with those developers and say, I know what the fix is for this problem.
Absolutely. Yes, absolutely. So this is really like one of my favorite things because it makes me a lot faster at fixing these type of issues.
Okay. What about flaky tests? My least favorite topic.
Yeah, I love this one as well. So same thing, right? You can run the build. Here I'm going to run it. You can see the timeline. You can see, and in this case, there's a failure in this one, right? It failed. And as I mentioned before, you can open it and see there's 2 test failures. All of that in one click. And what I did before was like, I asked, my build is failing. Were there failing flaky tests during the day? And same thing, it's going to be able to connect to all the build results, do like back and forth. It's interesting with LLM is that they sometimes take a different strategy if you ask things twice. And in this case, it says, okay, the test is flaky. It is designed to fail randomly. Actually, we actually wrote a flaky test on purpose for the, but this one is like, hey, this one is flaky. You should probably have a look. Whereas this one is actually a genuine failure. It fails because of something, doesn't matter. And then it's like, hey, I can suggest a fix for the genuine failure.
I mean, this is really helpful because flaky tests are so difficult to track down. Firstly, you can't identify if they're flaky. And secondly, well, you can if you're using Develocity. And secondly, it can be difficult to track down the root cause of the flakiness.
Yeah, absolutely. I can mention that you can ask questions such as like, are there other flaky tests in a system? You can ask global questions. But let's go for the next one.
Okay, so we were on the topic of flaky tests, and one of the causes of some of these problems can be infrastructure. So I want to know, can you ask the AI, like, is this an infrastructure problem?
Wow, yeah, let's do that. So an example I have here is I ask, so I run the build, it fails, and say, hey, my build failed. Is it due to an infrastructure issue? And guess what? It's going to look into your build, look if the same thing happens in CI, for instance. And I won't go into the detail about everything. It would take too much time. But basically, it is investigating all the failures, both the local ones and the CI one. And in summary, at the end, it tells you, well, your build is due to two separated test failures. One failure points to an infrastructure issue due to an external service not being reachable, whereas the other one is a code-related issue. And the infrastructure issue is present both locally and in the CI environment. So again, here, that gives you a clear analysis of what you should be doing. Maybe for the first flaky problem, which is due to the connection problem, you can talk to the central team, whereas for the second one, you probably want to fix it yourself.
Right, that helps you triage and find who needs to fix this problem.
Exactly.
So sometimes when I've got an issue, it can sometimes turn out that it's a problem with dependencies, but I don't always know that up front. All I know is there's a problem. So can we see an example like that?
Oh, yes. And on purpose, I will ask something like pretty open. In this case, so scripting, run a build, fails, and I'm asking, hey, what is wrong with my build? And it's a pretty open question, right? And let's see what it does. Oh, well, then it builds a strategy. It looks into the recent builds. It looks into the other ones. And basically at the end, it says, your build is due to dependency conflict with the Guava library. And then it explains why that's a problem. And then it has even provided a fix here, which corresponds to like updating the Guava library from 17 to 21. Yeah.
Right. So this one doesn't just identify the problem, it actually fixes it for you.
Yeah, you can ask it to do that as well. I could mention maybe before we go for the next is that in this case, as you can see, I was using the agent and Gemini 2, but in fact, you can actually use the LLMs you want for that.
Yeah, that's useful because everyone has their own preferred agent. So given what we've seen so far, we've seen that we can ask Develocity a bunch of questions via the agentic AI stuff. We can say, what happened to my build? What's going on? What caused this problem? And we can also ask it about other builds, compare it to the CI build or compare it to other developers' builds. So what's next?
The first thing is what we call one-click prompt. Today you have to type it, but tomorrow, very quickly, you're going to have like one click and you're going to send the right information to the prompt saying, hey, I want to investigate dependency issues, or I want to just simply understand why it fails. I want to know if it's infrastructure problem, and so on and so forth. And it's going to be a lot faster. We're going to be able to search for similar builds, show me something similar to my problem, and maybe how it was fixed. We're going to have a troubleshooting agent capable of, in the background, analyzing your problem and telling you, well, I see you got a failure here. It's most likely due to this or that. And same thing for the CI infrastructure, where maybe you want to identify some flakiness aspects, or maybe you want to understand when the builds are newly broken on the main branch and you want to understand what's happening. All of that in a proactive way. So basically, the IntelliJ plugin will make it super easy to interact with the LLMs. In fact, we are continuously adding new capabilities, right? We will enable it to collaborate very quickly and very efficiently. Just one more thing I'd like to mention, actually. You see, what we just demoed here is mostly developer focus. I'd like to show you something else. We can actually ask questions from the point of view of a central team as well. And I would like to show you what I've done recently, looking into some open source projects that are powered with the MCP server with Develocity. Here's an example. Here, what I ask is present, so look at the DRV data, so the analytics data that we provide from Develocity. Present the data as a table so that I can see where I should focus my efforts because things are broken. And here I'm using Cloud desktop, but again, it works with the other LLM as well. And this is very interesting. We can realize that this project here actually has a lot of failures. Well, 100%, that's a lot. And this is interesting. Cloud tells me, well, the infrastructure is completely broken. Do something, basically. And then it lists a number of projects. And every time it's going to say, well, for this project, it's most likely due to code and infrastructure issues, whereas this one is due to code generation logic. And this one is due to database connectivity. And this is an extremely powerful way for essential teams to understand what to focus their efforts on.
I really like this because it allows you to see not just one project, but multiple projects, like you said, so you can figure out what to focus on. I also really like the focus area because you can figure out, is this a problem I can solve or do I need to delegate it to someone else? It really helps quickly prioritize the problems. So, Laurent, thank you very much for walking us through all of these things and using it. I love seeing AI used inside the IDE, particularly for problems that isn't just code generation, like trying to solve problems that real developers have. So this is super useful.
Okay, great. Well, folks, this is all the time we have for today. I want to say thanks to Trisha and Laurent for this great conversation and especially the demos. People were enjoying them, I believe, and thanks to our audience for tuning in. So thanks again and have a very productive day.